Okay, so we're looking at number 25, and here, when Richard Zucker, I love these names, was born, his father deposited $2,000 in his name. The account was paying 5% interest compounded semi-annually. If the rate did not change, what was the value of the final account after 15 years? So they want to know the final amount after 15 years, given that we invested an initial amount. So we want to know the final amount, so we're going to be using this formula here. That the final amount will equal the initial amount, which is 2,000 times 1 plus r, so 0.05 divided by n. So semi-annually, so that's twice a year, twice a year. Again, n is 2, and after 15 years. So again, just walking through the calculations. Quiet, Mr. Computer. Okay, so we've got 2,000. I'm going to do the 0.05 divided by 2, add 1. I get 1.025. 2 times 15 is 30. 1.025 raised to the 30th power is 2.097567 blah blah blah. Multiply that by 2,000, I get 4195.1, and I'll round this to 4. And check to see if that's good. 25. Yep, so that part's looking good for A. And then of course there's a part B. If the money had been invested at 5% compounded quarterly, how much would the account have been after 15 years? So same idea, just different numbers. So we're still investing $2,000, but now the rate is still 5%, but they're compounding quarterly instead of semi-annually, so now you're compounding 4 times a year. Again, n is 4 and t is 15 years still. So just cranking this guy out. So 2,000, 0.05 divided by 4, add a 1, I get 1.0125. 4 times 15 is 60. This 1.0125 raised to the 60th power is 2.10718137. Multiply that by the 2,000, and you get 4214.36. So that's how much money I'll make then. Let me just check that. 25. Yep, looking good. So we're doing number 29, and it says that this guy invested $6,000 at 8% compounded quarterly. 3 years later, she withdrew the full amount and used it for the down payment on a house. How much money did she put down on the house? So it looks like she invested $6,000, so that's how much she started with, and they want to know how much she finished with to put into her house. So we're still using the same formula because we know how much she started with now. And we want to know the final amount she'll get if she invested $6,000. We get 1 plus, the rate is 8%, so 0.08, compounded quarterly, so 4 times a year. Again, n is 4, and the time is after 3 years. So, I'm just going to plug all this in. So, 6,000, 0.08 divided by 4, add a 1, so I get 1.02. 4 times 3 is 12. So 1.02 raised to the 12th power is 1.268241795. Just multiply that by 6,000, and you get $7,609.45 that she'll have to put down for her down payment. So let me just check to make sure we're good. 29. Yep, looking good. Excellent. Okie dokie. So this one kind of practical. Annual percent yield. You see that a lot. And they say you've got 2.4% compounded monthly. And they want to know what the annual percent yield would be. So you're going to figure out if you have 2.4% and you're compounding it monthly, how much you'll have at the end of the year. And the starting amount actually doesn't matter at all. And the book tends to use just starting off with the dollar. So let's say we want to find our final amount. If we just started off with $1 and we just use our formula, 1 plus the rate is 0.024, again moving that decimal 2 spots, and we're compounding monthly, so 12 times a year, and again n is 12, and we want annual percent yield, so we want the amount after just 1 year, so t is just 1. And so we're just going to crunch this out. So 0.024 divided by 12 gives you that, and add 1, so 1.002. 12 times 1 is 12. So 1.002 to the 12th is 1.024265. And if you multiply that by 1, you still get 1.024265. So if you started off with $1, you end up basically with $1 and that much cents. So so the amount you earned was 0.024265, and that's 2.4% of the original amount. So because that's 2.4% of 1. So basically, you start off with $1, kick off that decimal, and change that to a percent. So the annual percent yield should have been 2.4%. So you started off with $1, you made that amount is 2.4% of $1.